Welcome to Rich Planet TV. I'm Richard D. Hall. Here is a message to all people who have received a COVID-19 injection. Before you received your injection, did you acquire a sample of what was going to be injected into you? And did you then examine it under a microscope? You didn't. Oh dear, because if you had, I don't think you'd have had an injection. In today's show, we are going to be discussing the evidence found by scientists who have obtained samples of COVID-19 vaccines and have examined the contents under their microscopes. Those who have been campaigning against the use of experimental mRNA vaccines, such as Mike Yeadon and Vernon Coleman, I will ask you the very same question. Did you acquire a sample of COVID-19 vaccine, and have you had it examined under your microscope? If the answer is no, then how do Mike Yeadon and Vernon Coleman know that mRNA, which makes a spike protein, is the predominant thing that's inside the vaccines, and that there's not something completely different? Because those who have bothered to look, it seems, have found something completely different. Is the whole mRNA spike protein narrative just a cover story? Is it a global, phony bone of contention? I'm guilty too, mind. I featured a scientist on this show talking about spike proteins produced by mRNA instructions and how they could be characterized as prions. He or she is saying exactly the same thing on mainstream media.
I've done a lot of research, and I really am beginning to understand exactly how the process takes place, and it's very disturbing.
Now, the neurodegenerative aspect of this that you specifically highlight from your research, explain that if you can in layman's terms.
Yes, I'll try to. And of course, the science is never easy, but it's quite fascinating what happens. The vaccine gets injected into the arm. The muscle cells get very upset. They bring in a whole bunch of troops. The immune cells come in, take up the vaccine themselves. They take up the nanoparticles. They start making spike protein. The particles basically get your cells to produce lots and lots of spike protein in a hurry. Spike is the most toxic part of the virus.
But she is speaking from what she has learned from scientific literature and from previous studies of mRNA technology used on animals. She's not speaking from knowledge of what she has observed herself with her own eyes from an actual COVID-19 vaccine vial. Knowing just how duplicitous the system that controls our government is, any debate about COVID-19 vaccines that is not based on independent forensic examination of the vials is just complete hot air and helping to prop up a possibly flawed official narrative. It's quite obvious to any person with a brain that the vaccine doesn't do what they claim it does, and that's because the vaccine isn't what they claim it is. Its true purpose can only be determined by forensically examining the contents of vaccine vials. If you are going to solve a crime, you must forensically examine the actual weapon, in some people's cases, murder weapon. If you are going to solve a crime, you cannot just blindly believe what the government and pharmaceutical companies say about what is in their so-called vaccine. We cannot trust them. Now, I'm hearing people saying that the tide is turning. Mainstream media's attitude is more skeptical of COVID. That's because the mainstream media has already done its job and got 80% of the population vaccinated. They know they're not going to get the remaining 20% jabbed just with media propaganda. This is why they are now trying to change the human rights law so they can go after the remaining 20%. So yes, the attitude may appear to have changed slightly, but not for any good reason. It's just reputation damage limitation and letting some steam out of the cooker. Simple as that. It's not because the attitude at the top has changed. Now, in previous shows, I have mentioned studies that have examined the contents of the vaccines, and today I am going to go into more detail with this very complicated topic, a topic which everyone needs to be involved with. To help me do this, I would like to introduce David Ferguson, who has studied in depth the various reports and images that have so far been made available by a number of independent groups. Welcome, David.
Well, thank you, Richard, for inviting me to be on your show.
Okay, so you have a degree in history, which
That's right,
might not be
originally.
applicable to this sort of research, but just
Well, that involves research as well, I guess.
right, and also software. So just give us
That's
a little
right.
bit of a background on yourself and why you think this subject's so important.
Right. Well, as you mentioned, I did start out with a history degree, but I rapidly got a job as a software developer, and I've worked for 25 years developing software, most of it as a contractor. So I worked on a variety of projects, a C++ software developer in the main, so I worked a lot of engineering type projects. And a lot of the work I did, particularly towards the end, involved network programming, which is relevant to the technology that we're looking at.
Right.
And I've got some background and knowledge of the sort of electronic components, that kind of
Right.
knowledge, which again is useful for what we'll be looking at.
Yes. So one of the things we're going to suggest is that it looks like there's nanotechnology being put in the vaccines, and we're going to go into that in some depth. And nanotechnology now involves a lot of, as you just mentioned, network components, let's say, a network transmitters and receivers, and the transmission of data, which
Well,
you're
yes.
very well versed
Well,
on.
and the topology of networks, the design of network, the protocol, protocol layers, stacks, protocol stacks.
Yeah. Which in the human body it's similar to, but has fundamental differences to protocol stacks in, let's say, using copper wires.
Well, that's right, and even wireless networks still hold by the sort of OSI 7-layer stacks, but in this context they have to simplify and design it in a sense that mirrors the application as well, whereas wireless and wired network stacks tend to be generic. In this case they need to be application specific, really.
Yeah, and we are going to mention various scientific papers that have been released about nanotechnologies that we think is similar to what's in the vaccine, and a lot of that includes papers written by the IEEE.
That's right. Well, they draw up the specifications, and although their specifications for intra-body networks are quite vague, they do exist.
Right. So although you might think that what's inside a vaccine requires expertise from, let's say, a microbiologist or something like that, there's a lot more to it than that, isn't there? There's other fields of expertise.
Microbiology is about a third of it, I would say, and 2/3 of it are in terms of what people would understand as IT type technology, that is microprocessor technology and software, although there's probably no software as such involved. But think of, you can either implement logic in terms of logic arrays of hardware or as software, and I think it's more likely logic arrays that are doing this at this stage.
We'll come on to that when we go through the various components. Now, we're going to look at a lot of images today of what people have taken using powerful microscopes, and there's a large variation in the different groups, as we'll see. Can you just make a comment about that? Just prepare people for what they're about to see, David, in terms of the variation and how, when you're looking at a microscope slide, sometimes it can take quite a bit of interpretation, because you're not looking at a scene out of a window. You're looking at something which has been highly magnified, and it might look rather different in certain ways. So do you just prepare people for what they're about to look at?
Yes. Well, for a start, we don't know what this technology is. So we are trying to interpret it based on scientific papers and the images in those papers. So we could get that wrong. We've got to say that, we can't really be certain about a lot of it. Some of it I think we can be. But we're going to look at a number of different studies, and one of the things we're going to draw out today is the range of studies that have been done, because that's not something that's generally being covered in the alternative media. People have just put up their individual studies, but not necessarily drawn out the common characteristics across those studies. So I think that's one of the things we're looking for, is common characteristics because that's the evidence that we're trying to accumulate here.
Right.
Perhaps a bit more than interpretation, actually.
Right. Now, recently somebody sent me 3 vials, 3 unopened vials of the Pfizer-BioNTech vaccine, right? And I've invested in a microscope and I have done some microscopy on one of the vials, all right? So I'm confident now that the images that we're going to show you, at least some of them are genuine, because I've seen the same things under my microscope that have been produced in certain studies, and I know that the vials were unopened because you have to actually break the cap when you take it off. All right, so I'm going to show some of that later in the program of me examining, doing my own research, but I have verified it to a certain point and seen similar images. So I'm confident that at least some of these studies are genuine that we're going to look at. And just to mention how difficult it is to get hold of these vaccine vials, I'm going to read out an email that I received from a pharmacologist who was working for the NHS. This is what he said in his email. Dear Richard, news from within a vaccine site. I've been working with the NHS on mass vaccination since January 21 in a lot of roles. The recent videos are very insightful, particularly the vaccine contents. So he's referring to some of the studies that we're going to refer to. Every mass vaccine centre in the UK and other sites, e.g. Boots, has a national vaccine protocol to destroy every vial with 2 different senior staff at the end of each day. The systems are also in place for counting in and out every single vial that arrives and leaves every site. All vials are disposed daily into a locked, coded clinical incinerator, waste system, or stored, again, coded locks for an NHS contractor to pick up daily for the clinical waste. If you want to get hold of vials, your best bet is to seek out independent pharmacies doing COVID jabs, right? So he's explaining there that it is difficult to get your hands on an unopened vial, but a number of people have, and they've examined them. And like I said, I would encourage Mike Eden to do the same, or Vernon Coleman and all of the people who were talking about mRNA, because for all, I think RNA may have been discovered in some of the vaccines. Possibly, we'll come on to that. We do, there's certainly something other than mRNA nanolipids in there, something much bigger.
A bit bigger, yeah.
Okay then, David, we'll come on to your study now, because David has very kindly put together this document, which I might make available as a download. Now, what we could do, there's various studies, various scientific groups have taken photographs of the vaccine using microscopes, and they've published them. So there's at least half a dozen that I'm aware of.
Yeah, well, there's more than that, but yeah.
There's more than that. Rather than go through each one in turn, what we're doing is we're going through some elements of nanotechnology, because the average person isn't that familiar with nanotechnology. We're explaining nanotechnology that has been developed over the last 20 years. We're going to give a brief, we're maybe going to go through 12 different types of nanotechnology or 12 different components. We're going to explain it, and then we're going to look at all of the images which seem to show that type of nanotechnology. And then we're going to look at multiple studies of microscopic images together, which support certain evidence.
Yes. Yeah.
So the first thing we're going to discuss is carbon nanotubes. David, do you want to just give a brief comment on what a carbon nanotube is and how long they've been around?
Right. Okay. Well, carbon nanotubes, I think, were discovered in 1991, and they're one of the allotropes of carbon that are synthetic. So carbon nanotubes can be created by folding a carbon nanoribbon, a graphene nanoribbon, should I say. And this is probably the method that's being used for these carbon nanotubes that we see in the body, both, as we'll see in some of the images, both in the body and in the vaccine. And I should also point out that these have also been discovered on the swabs used in the testing, right, and on the masks, that,
right,
the surgical masks.
Right. So carbon nanotubes are extremely strong for their size. They're 100 times stronger than steel.
That's right.
They've got properties of metals in that they can conduct electricity and heat.
Yeah.
And really, the graphene and carbon nanotubes and other developments are considered a breakthrough really in nanotechnology, enabling them to do all sorts of things on a very small scale that they weren't prior to 20 or 30 years ago.
Yeah.
So I'll just read out a little bit on carbon nanotubes from David's paper. Carbon nanotubes also possess high surface area, high elasticity, accompanied by ultra lightweight and excellent chemical and thermal stability. Owing to their high aspect ratio, they have the capacity to easily cross biological barriers, to be internalized by cells, leading to the use of carbon nanotubes for drug delivery as well as biosensing. So because they're made of carbon and our bodies are made of carbon, they integrate quite well with existing cells, so they won't be violently rejected.
Well, you actually do have to functionalize them still. So because of the high surface area and the fact that they have sort of spare covalent bonds as well, you can easily, what they call, decorate the surface with biocompatible molecules, which has a number of functions, one of which is to make them more biocompatible.
Right.
So,
right.
Yeah.
And I'm going to release a database that I've set up which discusses a lot of nanotechnology scientific papers. And if you look at those papers and you go to the brain control section, you'll find carbon nanotubes mentioned a lot in neurosensing and neuroactivation.
Yes, well, it's got a lot of properties which make it very suitable for this, and their papers talk incessantly about this. So as basically as an electrode for neuromodulation, both sensing and actuation. So they can be used essentially as a transducer in that context. So
just to interrupt you, a transducer is something which can receive information about something it's connected to. Yeah.
And it works the other way. It can actually convert an electrical signal into, say, movement or the release of chemicals from the surface of the carbon nanotube. So because, we should point out, carbon nanotubes are essentially two-dimensional objects because they're created from graphene sheets, and graphene is just typically one atom thick. Mm-hmm. So they have the perfect aspect ratio. That enables them to get into cells and to get in past the blood-brain barrier, but also it means you've got the biggest surface area for psychoelectrical stimulation. So they're very sensitive because they conduct electricity very effectively. The electrons are very free moving on them. So they're very sensitive. So any chemical or movement even that they detect because of their flexibility in the brain. So any kind of neural activity they'll pick up very easily and translate that into an electrical current, which makes them a sensor, a transducer. But it also can work the other way, so that a signal sent to them can then be used via an electrode process as a way of actually stimulating neurons. So
let's just spell that out in basic terms then. They can read what you're thinking and make you think something.
Well, I think that's the intention, yes. Yeah,
right.
I think that's what...
Potentially.
Potentially.
Now, when I first found out about carbon nanotubes, you often see diagrams and they look like engineering structures in terms of they're perfectly cylindrical and straight, but that's not how they appear in all of the studies we're going to look at, including what I've seen under my microscope. No. These things look far more biological, let's say. So do you want to just make a comment on that, the fact that they're not necessarily, just because it's what we think of almost like an engineered item, they're not like that, are they?
No, they don't. I mean, they have properties that make them look like some kind of parasite, worm-type creature, reacting to outside stimuli. For example, if you breathe on them, they tend to react. Now, of course, that is consistent with what I've just described as a very sensitive transducer. Right. They're picking up organic molecules from your breath, and they're reacting to it and creating electrical properties within the nanotube, which probably is what causes it to flex.
And it can react to electrical stimulus and heat as well.
Yes,
right.
Yeah.
All right, and so let's move on to the images then. So we're going to look at some images. This is, as I said, this is from multiple studies, and I have confirmed that some of these studies must be genuine because I've seen very similar things under my microscope with the vial that I've received, right? So we're not, we're not sure about every single study, every single image in every single study. We're skeptical of some of it. Are we, David?
Yes, we are. I mean, I think we have to. We know what we know because we've seen it under the microscope.
Yeah.
Right, and beyond that, well, I think we have to have a healthy dose of skepticism, but at the same time, we must report what what's been put out there.
Yeah.
So
right now, in David's document, he's highlighted 19 different sources of information. A lot of it's videos online that have presented studies. Okay, so those 19 studies are all listed at the end of his document. So the number in square brackets denotes which study it's from or which video it's from, and then they're then numbered. So we've got the first one is from study number 2, so it's 2001. So people can find out where what the source of the image is by looking at that number. Just explain that first. So the square brackets denotes the study. So if it's square brackets number 2, that means the first 2 images that we're showing there on the screen, they're from the same study. Okay, so just to point out that numbering convention. So the first image we've got there on the screen is an alleged carbon nanotube with a lot of sort of technical things at the end of it. So do you just want to start commenting on these images? You'll see various different colours in these images. The colour doesn't always denote anything. Sometimes colours are used in order to bring out detail. They're not necessarily the actual colour of the item.
That's right. So I would say, though, that some people have observed carbon nanotubes in other colours. Now that could be open to interpretation, but one of the things that it does put us in mind of are these Morgellons fibres. So at the back of your mind, although Morgellons tends to be a much larger object, or larger fibres than these are. These are much smaller here.
Yeah, so Morgellons, usually you can see it with your naked eye. Whereas you're probably not going to be able to see any of what we're looking at now with your naked eye. Yeah?
No.
So this is from Dr. Pablo Campra, who I've actually made contact with. We'll come on to that in a bit. And these are some of his images. So you just want to make
yes. So these are quite early images. One of Campra's early studies when he produced images, and this first image here shows quite a typical formation of a carbon nanotube with the sort of flayed ends to it. That's the first. If we go on to the second image here, another one from a similar study, a carbon nanotube showing flayed edges and quite transparent. The carbon nanotubes come in 2 forms, single-walled and multi-walled. Mm-hmm. The single-walled is just one rolled tube of a carbon nanoribbon. The others are tubes within tubes. We go to the next image. This next image here again shows a number of these carbon nanotubes. As you can see, some of them are more transparent than others. Mm-hmm. And again, the flayed ends on one of them, but in other cases you just get a tapered end. So those are just 2 characteristics, morphological characteristics of them. On to the next image on the Moderna. So Campra looked at all 4 of the common vaccine types. So what we're showing here really is that you find this in all of these vaccines. And here we've got a sort of an accumulation of different carbon nanotubes all relating together. And one of the interesting characteristics that you do see from time to time, to the point that it's worth pointing out, is this little tube that's sort of crossing over the larger tubes. I don't know why that is, but you do see it. So there may be something interesting to look at there.
That's a much closer up image.
Yeah, the close-up image there is just to give you some idea of the transparency, and also the fact that you can just see the surface is a little bit decorated there with other chemicals, other molecules maybe, which is the functionalization aspect of it.
Just to address a question early on, people might say, well, how do you know it's a carbon nanotube? Campra did do some spectroscopy on the samples.
That's right. He did a very detailed Raman micro spectroscopy analysis, which you can find online. in which he showed that these are graphene-based.
Right, which suggests that they
Yeah,
are
they are.
carbon nanotubes.
That's right.
Okay, so this is another study now, David, number 6, which is...
This is Dr. John B's study of Pfizer. So again, this is a study. So
this is a completely independent study to Campbell.
Yes, completely independent.
And he's looking at Pfizer and he's finding carbon nanotubes as well.
That's right. Yes. So he is, and some of the characteristics here, which we'll see in other images. That first image on the top left, you can see that there's an accumulation of other objects at the top, towards the top of it, which is something that which is characteristic. They tend to pick up these little spheres.
Right.
And another thing that I'll also note is below that image, you've got a carbon nanotube seemingly with a relationship with a piece of, I would think, is graphene oxide. And again, you can see that, we'll see that in later images. And those brighter colours in these sort of more dark field type microscopy denote some metallic substances. So you wouldn't find that on an organic substance, I don't think, those brighter colours.
Okay.
Right, we get the next scene. So 6004. Now this carbon nanotube is quite interesting, mainly because we can see the scale there, 50 micrometers, which if you multiply that, let's say that's 500 micrometers across, it's probably longer than that, but that's half a millimeter. So that's quite a long one, but it actually illustrates that these are significantly sized objects that you're finding in vials of vaccine.
Yes, yes. My microscope comfortably goes up to 1,000 times magnification, and I can see these items on 40. They look very small, and then up to about 400 I'm looking at them at. But I can confirm that I've seen very similar things to what's on the screen there. And we'll come on to what I saw in a minute.
Yeah.
And then we've got images from, is it Carrie Madej?
Yes, Dr. Carrie Madej released these images. She didn't actually do the study, but she witnessed the study. And so this is of the Moderna. And this is just a typical carbon nanotube. This is the kind of thing actually you see in the masks. Which there was a study by Dr. T in this country where she looked at, I think, 4 or 5 different masks from different manufacturers, and they all had these structures on them.
Right. So moving on to study number 9, image 7. So this is the Reutlingen study.
That's right. This is I think this is 9 is the Austrian study, actually.
Right, so
this is the Austrian part. Reutlingen had 2 studies, really, Bolentz, and this was a very impressive study, actually. They had a news conference last year, I think around September, October last year, and presented this evidence. And this is a carbon nanotube, and as I mentioned earlier, with another one crossing it, which is something somewhat characteristic. I don't know why that would be. I should also point out the other pieces of graphene oxide in that image. We're not really discussing graphene oxide today, but most people probably know about that by now. But
a lot of all of the nanotechnology components, or most of them that we're going to talk about today, are based on graphene, aren't they?
Oh yes, yes.
That's
graphene is absolutely the building block.
Because all the studies that I'm aware of are reporting graphene as the base, as a common material, whether it's carbon nanotubes or whether there's little blocks of it. That's, I would say, it's been shown by so many studies now. It's accepted, even though the mainstream are debunking it.
Yeah. Without graphene, they couldn't do any of this. I would say that. Without that material, they couldn't do anything.
Now, the next image isn't actually from a vial itself, it's from somebody's blood,
that's
that
right? Yes. So
this is the vaccinated person.
Again, that's right, from the Austrian study. They're showing a carbon nanotube in the blood. Well, I'll talk a bit more about the blood later as we see some better images of it.
Right.
But,
because the Reutlingen study, they weren't just looking at the vaccines, they were looking at blood from vaccinated people.
That's right, and also other pathology. In the first part of that study, you had the effects of this on tissue and on body, on organs. But
18003, this is from a very recent study from Argentina.
yeah,
Again, showing very similar structure.
yeah,
And then for the same study, 18004, we've got this, they seem to fold round in a loop. And it's been commented that's it's a three-dimensional structure in that it's like one of those party balloons that you would blow up. Do you know what I mean? In
Yeah,
other words, it's like it's not flat.
no, it's cylindrical really, but
They seem to do this characteristic sort of. I've seen this in a number of images where they seem to have.
yeah, they
this
do fold back, yes, yeah, on themselves. I mean, they're very flexible. That's one of the characteristics of them, as well as strong. So they can bounce back as well in an elastic sort of manner.
Okay, so we're on to Young.
Yes. Okay. I'll
Study
talk.
number 1 is David Young, is it?
Robert Young. So
Robert
this
Young.
is Dr. Robert Young, and what he's showing here is a carbon nanotube in the blood, and in his images, it looked like the red blood cells, which are those objects around it, were attracted to the carbon nanotube, which could be, I'm just speculating, that carbon or graphene loses electrons quite easily. So what could be here is an electrical attraction of the negatively charged red blood cells to a positively charged or oxidized carbon nanotube. So that's what we could be looking at there.
Okay.
And the next image is the same. You can see the red blood cells seemingly attracted to the carbon nanotube.
Okay. Moving on to image number 3 in Young study.
Yeah, and this is some dried coagulated blood with a carbon nanotube found in the blood. This is according to his.
And of course, this would explain a lot of the blood clotting
Yes, that's right.
issues that we've seen with
Yeah.
vaccinated people.
Oh yes, and we'll see that in the blood as we see some more studies. Yes, the coagulation.
So this is another study, number 5, where again we see blood cells.
That's right. So we've got this image shows images found by German researchers. There's a video on up on the internet showing this. And what you see here is a carbon nanotube in the blood with this blood formation known as rouleau, which is where the red blood cells lose their negative charge and start stacking together. And this is when you get coagulated blood.
Right. So in normal blood, you won't see all the blood cells lining up like a load of polo mints like we see in there.
They'll all be completely separate,
Yeah.
really equidistant from each other, not overlapping.
Yeah.
That's
So it's making the blood behave in a way which isn't healthy.
very unhealthy. I mean, the other thing that causes this kind of blood formation is electromagnetic radiation. That's being shown.
Right.
There may be a connection there as well.
So similar images, again from this German study, number 85.
This is from Reutlingen. Yes, this is from the. This is from Dr. Axel Boland, who showed his results in the Reutlingen conference.
And we see the same effects
yes,
on the
we do.
on
We
the
see
blood.
the same rouleau effects on the blood with these carbon nanotubes in these two images. Yeah, so this is, there's a number of people who have seen this. And again, we see the same, not quite as bad rouleau in the, this is Dr. Zandre Botha on the Stu Peters show. She showed these images, a carbon nanotube in the blood. And that blood is a little less rouleaued. It's going that way,
Right.
but it's not as bad as the previous images.
So we've covered carbon nanotubes. We're going to, we might discuss at the end why all of these things might be in the vaccine, right? But we're just looking at evidence of photographs of what's in the vaccine and how it relates to nanotechnology. That's what we're looking at the moment. We'll discuss the nanotechnology in more detail.
Yeah.
But the next thing that we're going to talk about in regards to nanotech is carbon nanofiber octopuses. Okay,
That's
so
right.
carbon nanofibers are characterized by being solid cylinders of carbon or graphene. They can grow as octopus-like structures. The nanofibers that form the carbon octopus could be useful to create connections or contacts for supercapacitors. They could also be used as junctions for synapse connections. So when they grow carbon nanotubes, they can grow them with different topologies. So they can grow them where you've got multiple strands coming from one point, which makes it look like a spider.
Yes.
Right. And this has been found in, well, fewer of the studies, but some of the studies.
Yes,
Yeah.
yes.
So, because I remember when this image first came out in study number 10, people were trying to debunk it or whatever. People were saying it was a parasite or what have you, or a creature. What are your thoughts on it, David?
Well, initially it was identified as a Hydra vulgaris by a few people, but I think now with what we've seen in the scientific literature, we can be fairly sure that this is actually a carbon nanofiber octopus. If we talk about this is this Dr. Zalewski, if I've pronounced his name right, a Polish geologist, I think, and he essentially he claims he grew this octopus from an egg that he found in one of the Pfizer vials. He attached it to some graphite tape, and over 4 days it grew, and eventually I think the tentacles grew to about 2.5 millimeters in length. And as you say, initially there was some skepticism about this because it seemed. But when I was reading through the scientific literature, I actually came across one article which talked about how you could grow these from adhesive tape. So,
So what we're talking about here then is synthetic biology.
Well, I don't know if I'd say it's biology, because at the end of the day, it is just carbon and mixed with some metallic substances like bromine and aluminium. Well, things like placing them, for example, would use this DNA method.
Right.
Whereby there may be DNA on the surface of both the location where you want to actually position the carbon nanotube, and maybe on the carbon nanotube itself. It's not quite clear how this mechanism works, so that the two relate to each other, and therefore it's able to position it. But from the point of view of growing carbon nanofibers or carbon nanotubes, no, that's just a chemical process, I guess.
Right. So because a lot of people looking at that image, they'll think, it's biology. It's biology.
They will think that, yes.
But you don't think it's biology.
No, I don't think it's biology at all.
Right.
No, I think it's.
Right. So 17001, we're looking at what we're looking at there, David.
Well, that's Ricardo Delgado from the Quinta Columna. He found one of these, I think, carbon nanofiber octopuses in one of the Pfizer vials he examined. So that's what that is.
And then we've got images from Dr. Carrie Madej as well, who also produced images of a very similar looking thing.
From the Moderna. So I think that's what she was looking at. So again, yeah.
Okay, so we come on to another area of nanotechnology. When we say nanotechnology, just to reiterate, we're talking about in vivo nanotechnology, which is put inside your body. There's other fields of nanotechnology with things that fly around and what have you. We're not talking about that. We're talking about stuff that can be put inside your body and perform some sort of function. Yeah. So we come on to graphene quantum dots. Graphene quantum dots are small particles whose properties improve due to the effect of quantum Hall. They amplify electromagnetic signals and with it emission distance, especially in environments such as the human body, enabling an analog wireless transceiver. The semiconducting properties of GQDs enable them to form a network through which they can monitor and effectively neuromodulate as neurotransducers. Graphene quantum dots are variable, and many properties, including the degree of surface oxidation, surface charge density, doping status, or links with polymers, can be dramatically different, yielding different interaction behaviors with biomolecules. They can be created through the degradation of graphene sheets. So again, this is something which requires graphene as its base component. Graphene quantum dots can acquire various morphologies, for example, hexagonal, triangular, circular, or irregular polygon. They are able to penetrate cell membranes. Graphene quantum dots emit fluorescence and so are used in drug delivery, biosensing and imaging with blue and green photoluminescence. So again, it's based on graphene like carbon nanotubes are, but this is something which is smaller. The other thing about graphene quantum dots is they can be used in a similar way to what we would use logic gates or electronics.
Yeah.
So
yeah, we'll be getting on to how they're used that way. I mean, you can think of them as the building blocks, really, of this nanotechnology. Without graphene quantum dots, a lot of it probably wouldn't work.
right, and apparently they can align in a long chain and create this similar function to a wire.
That's right.
They can pass either energy or a message along it, but without actually passing electrons.
That's right. Well, we might talk about that. That's the quantum dot cellular automata,
Yeah.
which is an equivalent to, if you like, the logic gates that you find in microprocessors. But as you say, instead of actually using electricity, they use quantum characteristics of quantum dots and of graphene at the quantum level.
So we've not seen many images of evidence of the quantum dots. I guess they are. You need a better microscope to find them.
Yeah. Well, just a little.
I'm not going to find them with this.
No,
right?
not easily.
So what's the image you've got on the screen there, David?
Well, I mean, what they're showing here. This is a still from a video, which I think was a German doctor took this, and he's identifying these quantum dots based on their luminescence. But those are the other blue things in there are red blood cells. And what you can see there is you can actually see quantum dots penetrating the membrane of those red blood cells. So the thing marked A, you can see the quantum dot on the exterior of the membrane of the red blood cell, and then C and B, you can see they're actually penetrated into the cell. So that it shows, one of the many characteristics of them, that that there's no barriers in the human body to these little objects.
Right. Okay, so we come on now to quantum dot cellular automata, right?
Yeah.
Quantum automata. So let me just, from my own knowledge of electronics, just to try and draw a parallel first before I read this. In an electronic circuit, you have a positive and a negative, and you have that provides energy to a circuit, so the electrons go around that circuit. With this type of automata, an automata meaning something that does something with information or bits of information. It's something that can store information, add information, or hold data, or something that a computer would normally do. But the way that it's done on a nano scale is you don't have a positive and a negative, so you don't have all of that problem of a circuit board. The automatas themselves, the graphene quantum dots themselves, exhibit different states, and it's that difference in state that brings about the ability to be able to store and process information. The fact that they can operate in that position or this position.
That's
so
right.
as soon as you've got that, you've got the building block of a 1 or a 0.
That's right.
Right. So it's using a completely different method that a microprocessor uses to achieve the same result, which would be to process information, pass information along a wire, what have you. But it's not a circuit board, it's not a chip, because I know that the government have been challenged on this. Does the vaccine contain microchips?
Yeah.
And they just say no. Well, it doesn't contain microchips. It contains quantum dot cellular automata. That's what it contains.
Yeah. I mean, we will probably be using terminology like chips just because it's a familiar terminology, and also we don't have the vocabulary to describe some of these things that we see. So we end up using the micro technology terminology, but it isn't really that, and I think it's important to understand that.
Yeah. It's something which can do something that a microprocessor can do.
Yeah.
Ultimately, if you were to build up more and more automata, more sophisticated automata.
Well, they can be very sophisticated, as I think you're going to read out. So.
Okay, so we'll read this. A QCA cell consists of 4 GQDs in a square array coupled by tunnel barriers, and 2 electrons are injected into the cell, which are free to tunnel between adjacent dots. Due to Coulombic repulsion, the two electrons reside in diagonally located dots representing two polarizations. The polarization of each cell is influenced by neighboring cells. Tunneling to the outside of the cell is not allowed due to a high potential barrier. QCA cell-based circuits can be built in a 3D form to allow greater complexity in a small area. So that what it's describing there is the ability to exhibit two different states and therefore being able to store information.
That's right. Yeah.
When the QCA cells are combined, cables and circuits are created where inverters, crossovers and logic gates are created, enabling the production of transistors, processors, transceivers, multiplexers, demultiplexers and consequently of any router. So it's performing the same function that many electronic devices perform, but it's not using a positive and a negative and a circuit in the way that an electronic circuit
no need
does.
for a circuit. No.
Right. A wire can be built by placing several QCA cells in a row, and again, you know, when you're using wires, you always have the problem of short circuits. So if something touches that wire, it's going to break. Whereas you don't have that problem with this nano stuff. It's not, you know, you're not going to get a short circuit as you would with a normal electrical chip. When the polarization state of the first cell of the array changes, subsequent cells tend to assume the same polarization state due to the Coulomb interaction effect, enabling the information transmission through the wire without electric current flow. So this sort of stuff, although they're suggesting that it's to be used inside your body, it could be used to revolutionize the whole of computing, couldn't it?
They're going to be putting this stuff everywhere.
Right.
You know, everything will have this in it. This is what they call an intelligent smart dust type sort of environment.
To develop a nano router requires cable crossings, which form logic gates, demultiplexers and parallel to serial converters. Demultiplexers are devices capable of receiving a signal at the input QCA and sending it to one of several output lines, which allows the signal to be routed for further processing. The parallel to series converter is a circuit capable of taking several sets of data as input, transporting them through different QCA cables and transmitting them at different moments of time through the output cables. The fundamental logic gates in QCA are majority voter and inverter gates, since any other logical component may be implemented from them, i.e. full adders, multiplexers and memory cells. So these are the building blocks of a microprocessor. The majority voter is only composed of 5 cells, 3 input cells, 1 output cell and a center cell, which is the decision-making cell. From the majority voter gate, other logical gates can be deduced, such as AND, stroke, OR gates. So this, just to summarize it, what this is describing is something that can go inside your body, which is completely unseen, which can do the same job that a computer can do. You wouldn't be able to do that with conventional microelectronics, because it's not going to be able to roam around your blood or your body, whereas this stuff can.
Yeah. I mean,
we're going to look at some more images now, which suggest, which may be consistent with quantum automata. Now, within this next section and the section on bow tie, antennas and self-assembly, where we discuss straight-edged, square-shaped items, some of these images might be explainable as being common salt crystals formed from saline solution. We're not certain what the square-shaped items are, but we've included them all for further discussion. In order to determine if nanotechnology is present, as I will discuss later, Mick Anderson is seeking to have DNA testing carried out which will compare known DNA nanotechnology sequences with vaccine samples, and then we'll know for sure. So do you just want to start with this 19001, David?
Yes, well, this was probably the first image that we saw of something that looks like what we'll call a chip. I mean, in many ways, the analogy between a chip and this QCA terminology does break down quite quickly, because the chip has etched, a microprocessor has etched out silicon, creating transistors. And when we talk about transistors in this concept, which we will be talking about to a certain degree, we're not talking about them used as logic gates. We're talking about them in a context of being a sensor, which we'll come on to later. So there are no transistors involved in this technology. Just these gates or these arrays of quantum cell automata, which would be on the surface of something like this.
Right. Although they can be used to make something similar to a field effect transistor.
Yeah, but they're used, I think, for a different purpose, not for gate arrays as they would
Right.
be in the silicon
Right.
world.
Right.
Right.
So this 9001, this is was this from the Reutlingen study?
Yes, that's right. This is, I think,
Well, there was
this
a
is
number of very
the
rectangular
Austrian-
objects that
That's right.
seemed to be moving around. One of them
Yeah.
looked like a SIM card. Although,
Yeah, it did. Well, we'll see that in a bit. So I think this was the first study that we really saw a number of these. It was in the Austrian presentation at Reutlingen. These are just a few stills from their videos, so it's worth watching their videos to get the real effect, particularly when we move on to what they called the SIM card, which was this very square object which moved around, which we have a couple of images of there.
Okay, yeah.
And then when we get to
The submarine.
the submarine, yes. Well, this was again from the. This is actually from Bolant's presentation at Reutlingen, and this was probably one of the first pieces of self-assembly that we saw, because this object, this is a still taken from the video, this was moving around quite purposefully. This object, as if it was on a mission. But I think we can see here that there is some clear signs that something's been assembled here. This isn't a random.
Right. So we'll come on to self-assembly in a later
We will
section,
do, yeah,
right?
yeah.
Again, another study, number 13, showed very similar rectangular sort of moving objects.
Yeah, this is allegedly from Dr. Andreas Nowak, who I believe is now deceased. That's another story. At the end of a video, which was actually anonymous, but people think that it was a video he took, there was almost a shower of these objects, and that was after he'd passed a magnet underneath a sample, which had produced some very dramatic effects.
Right.
So maybe, I don't know if that would be related to the shower of these
Right.
chips. But
So 18005, 18 is the Argentinian study.
yes, it is the Argentine study, and this was an interesting image. So they looked at Sinopharm, which is obviously a Chinese version of these vaccines. So I should point out that we've looked at Sputnik and Sinopharm as well in these other studies, and they show the same sort of characteristics. So it's not just the Western
Right.
vaccines. I think they've all got these same characteristics. And what we've got here is it looks like two, let's say, rectangular objects stacked together and surrounded by what we will come on to in a minute, which might be a microbubble
Right.
type structure. But it's an interesting image. We
Right.
don't know exactly what to make of it, but and then again, this is a Sputnik image from the Argentine study, and the object towards the bottom of the image, again, it's pretty much rectangular, but it just begins to show on the surface of that some other characteristics which might be indicative of QCA
Right.
circuitry.
Okay. And then the next one down is showing graphene next to what might be some sort
Yeah,
of
that's right. So
automaton.
there we get some of that multi-layered graphene oxide. The darker it is, the more layers of graphene oxide there are. And then above that, we have what looks like another potential rectangular object with markings on the surface, which again might be QCA type circuitry.
Okay. So moving on to the Pfizer vaccine now. These are Dr. Pablo Campa images.
Yeah,
An altogether far more straight-edged, uniform, microchip-looking item, and this is something that we're a little bit sceptical of. I mean, I haven't found anything like that in the vaccine that I've looked at. Nothing as straight-edged as that. What you're talking about is self-assembly.
Yeah,
Now,
self-assembly.
That might sound magical and fantastical to anyone who hasn't heard of it, but you go and check check on my database of all of the published papers that talk about self-assembly. This is something they've been working on for the last 10 years, how to put something in your body and then so it can then have the intelligence to assemble itself into something larger when it's in the body. They've been working on this, folks, for a long time. So this is not science fiction. It's not. We're not just making assumptions. We've looked at scientific papers which talk about self-assembly.
Yes, yeah.
Right. So we know it's a possibility.
So right. So what this shows here is perhaps a combination of two processes going on: a fractal process and a quadrangular process. These are two. I mean, obviously, the fractal process is a natural process, and what they're doing a lot in this self-assembly is they're trying to make use of natural processes to assemble these this nanotechnology.
Yeah.
So
I think Mick Anderson, who we're going to talk about a little bit later,
Yeah.
he's described the different types of self-assembly.
Yes.
One of which is related uses DNA.
yeah, well, they all tend to use DNA, but in slightly different ways,
Right,
I think.
okay.
Yeah. Yeah. So you can see a sort of fractal structure, but at the same time a quadrangular. It's a hybrid kind of formation there.
Right.
So then again, the next image is you can see the surface structures. For example, there seems to be a sunken area on that next image, 1503. I mean, what you've got there is that I think you can just make out that it's forming some kind of surface within that chip, that rectangle. That there is a very regular surface as well as that region.
Yeah. So this is we're coming on to what they believe is nanorouter in this.
That's
image.
right. So this is Mick Anderson identified what the markings on these chips. So what Mick Anderson has said about these chips is first that he's matched up the images which look like little scrolls on those chips with QCA designs, that's quantum cellular automata designs for nanorouters.
Yeah.
So he suggests that these might be nanorouters.
Yeah, we'll come on to Mick Anderson. Mick Anderson's probably done the most in terms of interpreting.
Oh yes,
the nanotechnology.
easily. I mean, we're following in his footsteps really here in many ways. If they're using logic gates, they're using quantum cellular automata, which if they want to do anything, be able to do anything they will need.
Right, so we come on to nano antennas now, which have been developed, which work inside your body. I'll just read this. A requirement for nano antennas is simultaneous wireless information and power transfer. Since electromagnetic waves carry not only information but also energy, antennas capable of converting an EM signal into a direct current using a ultra-high speed rectifying diode are required. Rectifying antennas, or rectennas, based on carbon nanotube arrays have been proposed since the discovery of the unique antenna capabilities of carbon nanotubes in 2004. In 2015, Kohler et al. Provided the first demonstration of optical rectification accomplished using a forest of vertically aligned carbon nanotubes which act as nanoscale antennas with excellent absorption properties. Carbon nanotube insulator metal tunneling diodes fabricated on top of the array are ultra-fast rectifiers that generate a direct current. The achievable energy conversion is approximately 85% efficient. Graphene nanoribbon-based nanopatch antennas and carbon nanotube-based nanodipole antennas around 1 micrometer long resonate in the band 0.1 to 10 terahertz. Right now, so this is something which I've looked at a lot of these papers on intra-body communication systems, and they all come up with that frequency band range.
Yeah.
So this is, you think of 5G, you think of 29 gigahertz, right? So go up to 1,000 gigahertz, or well, 100 gigahertz, let's say, which is 0.1 terahertz. So we're talking something 10 times faster than 5G and above. That these, and the reason why that they're operating so fast is because they're so small. The resonant frequencies are in the terahertz band. Now, they've developed all sorts of techniques. So just to try and explain it, you've got a number of things in your body, spread around your body, which need to communicate with each other, like a mini wireless network inside your body. But the waves are going through the skin. The electromagnetic waves are going through your skin at terahertz frequencies, and they've developed these nano networks that will fit inside people's bodies. It's all fairly new to me. It's the fact that they've developed discrete wireless networks that can fit inside your body, working at terahertz frequencies. And it's all based on graphene. Graphene bow tie antennas with 2 triangular sections. The thickness of the antenna is 100 nanometers, and nanodiodes made of graphene located in the middle of the whole area rectify the AC flux to DC. Plasmonic graphene nanoantennas with a geometric diode such as bow tie can also collect energy from the infrared spectrum, which guarantees a constant flow of energy. So this is one question that a lot of people have. They say, well, okay, where's the power coming from for these systems? And they're self-powered through these things called rectennas. Bow tie nanorectennas take only 6 milliseconds to charge a nanocapacitor rather than 6 minutes for a carbon nanotube array. Graphene nanomesh could act as a capacitor. So capacitors can store energy that can run these quote-unquote circuits. Rectennas can operate in a matrix or array. The approximate output power of a single rectenna is 0.11 nanowatts. More elements connected in series can increase the production of current and power. So people might ask, well, what the hell is this used for? Let me just give a quick example to try and put it into context. Let's just say that you've got nanotechnology in your body, and you've got biosensors in every single one of your 80 organs, right? And they are then going to communicate whatever they find in those organs to a central wireless network. So potentially you could have an automata which knows what's going on in every single organ in your body, and that information has been harvested and then possibly sent out to the outside world. And the same with the brain. Because Anderson reckons that the systems are split into 2 distinct areas, one monitoring your bodily system and the other one specifically for your brain. Okay, so you think there's evidence of antennas, and I think this is quite strong evidence, in my opinion, with the antennas that Mick Anderson has identified.
Yes. Well, so I mean, they had 2 options in the literature for antennas they could use. They could usually use arrays of carbon nanotubes with these insulator metal diodes to rectify the current at the top of them, or they can use these bow tie antennas, which have the a MIM, typically a MIM ultra fast rectifier in the centre between the 2 elements of the bow tie, the triangular sections.
So I can show an image from one of Mick Anderson's paper at this point, David, where he actually compares an image from scientific literature showing a bow tie antenna with one of Dr. Pablo Campra's images, and it is pretty similar.
Yeah.
So this image, this Pfizer image, 14, number 10.
We've got some fractal structures there. Now, in that image there, there's another option for antenna, which is a fractal based antenna, and there are papers describing these, fairly recent papers, and they describe the uses of fractal antennas. There's 2 or 3 essential benefits of fractal antennas. One is multiband, that is that they can concurrently transmit and receive on different frequencies. And secondly, they can cover a much longer, bigger range of frequencies more easily because they've got multiple antennas. And thirdly, they require fewer, I hesitate to say electronic components to control them, but they're simpler in terms of components.
It can be made out of one piece.
That's right, one piece. And also higher gains in the sense that they can be more directional, but in many ways they also respond to radiation from all directions. They're sort of omnidirectional, perhaps more so than some of the other antenna designs. Also in that image, I just would note on the right hand side we see a carbon nanotube straddling a chip, which is a feature which we should take note of for later.
Right, yes.
Yes, there is there.
So it looks like we've got some automata connected to a wire,
Yeah.
which,
Uh,
yeah, all right.
And the other thing I would say is that only some of those, what I think would be blobs of hydrogel, have got those fractal structures on them. Interestingly, others don't. And you'd have
Right.
to ask the question why that would be.
Right. So we've mentioned self-assembly before, just to try and spell out why that would be needed. If you want to install something in someone's body that will fit inside a vaccine and go through a needle, the components have all got to be absolutely microscopic. They've got to be tiny, and you might want something that's actually larger than that. So one solution is to inject it, and then those parts then self-assemble, which sounds incredible, but there are a lot of scientific papers being written about this. David.
That's right. Well, there's two elements to self-assembly. One is in a manufacturing process. So a lot of the papers do talk about self-assembly in the context of manufacturing nano devices, where conventional lithographic techniques, they're not really capable of doing it anymore. That's the way, for example, that you would etch out silicon into transistors. Well, when you get down to the nano level, then that becomes very, very difficult. So instead, when it comes to self-assembly, they try to look at how the biochemical molecules and whatever, how do they self-assemble?
Yeah.
And they're trying to, in many ways, follow
Right.
that method
So
as
they're trying
well.
to mimic biology.
Yeah, they are.
And they use DNA as
That's
the
right.
core
Yes.
tool
Yeah.
to get something to self-assemble.
Yes.
Right.
Yeah.
All right. Yeah. New approaches rely on the use of nanoscale templates made of synthetic or biological materials to leverage biology with its inherent self-assembly capabilities. Bottom-up fabrication exploits the intrinsic properties of atoms and molecules to direct their self-organization. Right. DNA origami is a technique that uses hundreds of short DNA oligonucleotides to fold a long single-stranded DNA molecule, which is called a scaffold strand, into various designer nanoscale architectures. The DNA structures are 100 nanometers in diameter and approximate desired shapes such as squares, discs, and 5-pointed stars on the 100 nanometer sized DNA shapes defined by raster fill. DNA's 3D double helix structure gives more advantages than other materials in guiding nanoparticles to 3D ordered assembly as well as 2D. All right. So it goes on. For example, the DNA scaffold molecule provides the address for the precise localization of semiconducting SWCNT field effect transistor. DNA origami has dramatically improved the complexity and scalability of nanostructures, and with its high degree of customization and spatial addressability, it provides a versatile platform with which to engineer nanoscale devices that can sense, compute, and actuate. So you think some of the images provide evidence of self-assembly, some of which we've already looked at. So this one from Carrie Madej, I think,
Yes.
4005. What's that one showing, David?
Well, one of the techniques, if you like, the basic techniques to kick off, this is what Mick Anderson has proposed, is that they use a technique known as Tesla-phoresis, which is use electromagnetic voltages, if you like, a voltage field, to direct the particles into basic structures, for
Right.
example, chains. And I think in this image here, we're going to see that these particles are being directed into a chain. Now, this is a technique which you can see them using in a manufacturing plant, but this is actually taking place on a slide under a microscope.
Right.
So I think that there are other methods that there may be that they can achieve the same as Tesla-phoresis. I mean, you can watch videos on YouTube from Rice University showing Tesla-phoresis, which involves a Tesla coil to generate a very high voltage near field.
So you've got an image from Reutling in there that you think might show
That's
evidence of
right.
self-assembly, which looks a little bit like an old-fashioned mobile phone.
Yes, well, it starts off like this. Now, this is the first time that we saw something that might resemble some of the images we see later. Now, I wouldn't say it does look exactly the same, but that, according to Dr. Axel Boland, became the next image.
Right. I mean, this does look like some of Canberra's other images.
Yes, it does, yes,
right?
yeah.
So we've got two completely independent studies there showing similar structures.
Yeah.
So that the device that we see there in that image, 8003, became 8004.
Well, he said 3 months later.
3 months later.
Now, I suspect that joined up with other components to create that. I don't imagine he monitored the whole thing, but you'd have to ask him. But we're seeing these sort of quadrangular structures with these surface features, which in this image look more like a sort of scoring on the surface than perhaps later images, but it's very similar. And that's the first time we saw anything like that. I mean, when I first saw that image, it was quite surprising to see that.
Right. So we think the more sophisticated images might be evidence of something further down the line in terms of its self-assembly.
Yeah, yeah.
So 9004, what we're looking at there.
Right. Well, this comes from the AstraZeneca, and I think this is the Austrian study, and they noticed these chains that were forming. Now, I'm speculating that these chains. I mean, this is complete speculation, but we know earlier we mentioned arrays of these antenna, these rectenna, or arrays of anything that could sort of generate power, really. I mean, they could be piezoelectric, zinc oxide type generators. That's mentioned in the literature quite a lot as a method for powering these systems. But if you wanted, I mean, it's worth just discussing this, but if you wanted to create significant amount of power, for example, for communicating outside the body, which would need somewhat more power than the intra-body network, then you might want to create arrays of power generating devices linked up in series like this.
Right.
So it's just a speculation because I don't know what else they'd be used for.
Right.
If we look at the next slide, this is a close-up image of that. So, I mean, they look fairly regular, those structures. So they're definitely of the same type, I would say.
You could be trying to create a wire of some type.
Well, it could be a wire. It could be a wire.
What do you think it could be to do with
power? I'm just speculating because I think they need to create, and then they have mentioned they need to create arrays of these things to create power. So I just thought I'd throw that out there, and that's the nearest image I've seen to anything that might be that. That's all. And the next image is the same. Right. So then we move on to this is the Argentine study. So what we've got here is some self-assembly. Possibly this is similar to the Tesla phoresis process, but something has basically drawn these elements into this chain.
Right.
Clearly, I think we could say that's self-assembly because that didn't come out of the needle, I don't think, like that.
Right. And 18002.
Again, in the Sputnik, I think we can see the process of self-assembly going on there. But there's some slightly different sized objects. And these remind me of something, again, we'll see in a bit when we talk about sensors and actuators.
All right. Okay.
Well, again, we can see in the AstraZeneca, again, a structure that appears to be self-assembling. I would say that rather than it coming that way. I have no idea what it is, really. And then the next lighter image there.
Yeah, just keep going.
Keep going. Right. And again, a very square-like structure with perhaps either a sunken or a raised area in the middle of it. Another structure, obviously from a number of combined structures, I think. And again, looking at these images just to see how many of them there are. Again, another image there with sunken areas. And now, yes, another sort of oblong structure there. Another sophisticated construction. Okay.
In these later images, you've got the chip-looking objects as well as carbon nanotubes.
Right. So what we've got here is we've got a carbon nanotube that seems to have some relationship with the chips.
So this is from another study. You've got an image.
Yeah, I've just wanted. This is from Dr. John B, and I'd just point out that he also noticed a similar kind of construction in that top right image to some of the images that we saw from the Argentine study. Almost a ribbed type structure.
Right.
But he noticed that.
Okay. These components, if you like, they're in a substrate, as you mentioned.
Yes,
They're in a fluid, right?
Yeah.
So is this what they call hydrogel?
Yes, well, we suspect this is hydrogel.
Right.
So what's been noticed is that as the samples dry out under the microscope, any sort of water or whatever evaporates, and we're left with this sort of substrate, which appears to, when Dr. Kamprad did his Raman spectroscopy, he noticed this 1450 peak, which comes out of the spectroscopy, and Mick Anderson did an analysis where he looked through the scientific papers to try and find out what that 1450 would correspond to. Mm-hmm. And in my opinion, the most likely of the candidates he found was polyvinyl alcohol hydrogel.
Right.
Now, polyvinyl alcohol crops up in a number of places here. For example, being used to coat carbon nanotubes to make them more biocompatible.
Right.
Also, it helps in the process of turning them into electrodes as well.
Right.
So we can speculate maybe that the substrate is maybe polyvinyl alcohol. There are a couple of other possibilities, but this polyvinyl alcohol can serve perhaps a number of functions. One of which is to help with the biocompatibility of this technology, but also because it tends to have electronic or electrical capabilities, it might also help in the self-assembly process.
Right.
And also as perhaps another mechanism of communication between these different components.
Right, right. And there are some images, for example, number 217, clearly it looks like there's a blob of something that the chips are within.
That's right.
So you think that's could be a hydrogel?
Gel blob, yeah.
Right.
We tend to see a lot of them sat in these blobs.
Right.
So and then from the Argentine study in the Sputnik again, this is another hydrogel blob. There's a chip sat in it, but that substrate does. I'm be fairly sure it does play a role here.
Right. Another component of in vivo nanotechnology is are sensors and actuators. So if this technology is going to interface with the body, it needs to be able to sense what's going on in the body and make things happen in the body. So that's basically what we mean by a sensor or an actuator. And a node is something which takes information and then sends it on its way. So I'll just read this. A generic nanosensor node includes an energy harvester, a communication mechanism, some processing logic with nano memory, and a module for sensing and actuation. Nanodes include graphene quantum dots, swimmers, or graphene nanoribbons. These have all been observed in blood samples from vaccinated people. The sensor is able to detect an optical, biological, or mechanical event with high sensitivity and converts the response to an output electrical signal. A carbon nanotube can be used to build a field effect transistor whose on-off threshold voltage depends on the carbon nanotube's physical properties, such as shape and temperature, or the presence of a specific type of molecule. The large surface area and the excellent electrical conductivity of graphene allows rapid electron transfer that facilitates accurate and selective detection of biomolecules. The actuator responds to an input electrical signal to perform the administration of drugs or perform neuromodulation. Graphene oxide and R-graphene oxide are used for drug delivery. So within this nanotechnology, we've got systems that can carry something within inside it, and then on a particular trigger or a particular instruction, it can release a drug into a specific part of the body. So this is standard drug delivery techniques. So we don't know that that's not even incorporated into the vaccine. There might be some actuation in there.
Well, these sort of artifacts are, present in the vaccine. So we don't know what they're for, but we can identify quite a few, I think, of these actuators and sensors, but more actuators actually than sensors.
If you're not getting this, folks, this is the crime of humanity. This is the biggest crime ever being committed against humanity that we're talking about here. We're talking about the introduction of some sort of communication stroke actuation system into the human body without the permission of the world's population, against their wishes. I can't overstate the importance of this, what we're discussing now, and this is where the debate needs to be. Not talking about COVID, not talking about prime ministers' parties, talking about what is the poison, what does it contain, what's it for, how does it work? Because most scientists haven't bothered to look inside a vial, right? What we're showing you is what the weapon consists of. This is where the debate needs to be. And if you've got this in your body, you need to think carefully about why you allowed it in your body and what is really in your body and what it's going to do to you. And what are you going to do about it? Are you just going to sit there and accept it? That you've everything that you've seen so far, that you now know is in your body. I haven't shown my images yet. We'll come on to those. Anyway, so you think that there's evidence shows that there's actuators within the vaccine, which is something which is going to change something in your body. In other words, it's going to, at some point in time, it's going to introduce an effect on either your brain or your organs or whatever it might be, which could be a release of a drug, or it could be an electrical stimulation, or it could be a physical actuator that stops blood flow or that causes a brain hemorrhage. It could be anything, couldn't it?
That's right, yeah. I mean, for sure, we've already discussed carbon nanotubes, which if you look at the first image we're looking at here, you can see on the top left a pair of carbon nanotubes. But if you look at the image on the bottom right, what you've got there is a carbon nanotube that's got a couple of components attached to it. So what you might surmise from that is that those two components attached to it might be what they're going to activate with.
Right.
So because of this affinity for that carbon nanotubes have for biological molecules and other elements, then they're ideal for transporting drugs to different parts of the body. So at the very least, the carbon nanotubes can serve that function. But as we'll see, there's some other other types of actuator that we found as well. So go to the next.
Yep. So 7001.
Right. So that previous image was Dr. John B looking at the Pfizer. This is Dr. John B looking at the Moderna. And what we see here is what have been described as colloidal beads. Now what these are swimmers. So what they're designed to do is to swim around the body with a sort of flagellar motion. And they're made up, we think, of a carbon nanotube which attracts these sort of spherical, perhaps magnetic beads, which are laid out along the length of the object, perhaps with a larger bead as a head, if you like, at the start. And this is what looks like being assembled here in this image from the Moderna. So these have a sort of swimming motion. This next image shows again the same kind of constructs taking place in the Moderna that Dr. John B showed. And also, I'd just point out in this image that these circular objects as well that you see round about, which we'll come on to, they're also involved in this. In fact, we'll come on to them next.
Right, so 11001, very different, striking image now.
Yeah, this is an image Dr. Zondre Botha presented on the Stu Peters show. And these are microbubbles, which again can be coated with that polyvinyl alcohol I mentioned earlier, which gives them a sort of magnetic quality as well, which allows them to be directed electromagnetically. Now, these microbubbles are specifically in the literature for drug delivery. So these are your classic actuator. So these are injected into the body, guided perhaps using ultrasound or using electromagnetic frequencies to a particular part of the body, and then using a particular frequency they burst and deliver their payload.
Right.
At that point, there's a number of images there. I mean, they have this very regular sort of hexagonal structure, so they have 6 potential connections, so they can be formed up into these arrays as well as operating independently.
Mm-hmm.
And then...
And Camper's found something very similar.
That's right. So he found them in the AstraZeneca and the Pfizer. I think these images from the Pfizer.
Some people might say, well, hang on, is that not the nanolipids we're looking at?
Well, these are far too big for nanolipids, because nanolipids are nano by
Right.
definition.
Yeah.
These are in the micro scale. So
this is, you know, we're not mistaking this for what should be in the vaccine, are we?
No,
This is something completely
no,
different.
no.
This is potentially, there's a payload of drugs within the vaccine that could be just sitting inside somebody's body that hasn't been released yet.
That's, well, some people have hypothesized about what that might be about. Yeah, what you've described might well be the case, that they're sort of dormant, waiting to be released.
It could be some drug that they've decided is going to help anyone who gets cancer, but again, it could be something that just terminates your life, or well, whatever they've decided to put in there.
That's right. Yeah. Okay. So we're back to here with the carbon nanotubes, but in this case here we've got carbon nanotubes with crystalline structures on one or both ends. Now these crystalline structures present even more of an electrode capability to the carbon nanotubes, which renders them even more of a sensor or potentially an activator, actuator as well. So, but we've seen quite a lot of these sort of images, so if we go down, we'll see more from Campra, a close-up there of this sort of crystalline structure attached to a carbon nanotube.
Right.
And again, we see this bluish one. Again, I don't suppose we can say it really is blue, but I wouldn't rule out that there's colour involved, but again, on each end it's got apparently some kind of crystalline. It certainly reflects a lot of light under the microscope. And these are, you know, sort of functionalising these carbon nanotubes for probably a particular use.
Yeah. And just to reiterate, in the scientific literature, the carbon nanotubes are often associated with brain interfacing, and connecting to individual neurons inside the brain, or even creating an entire mesh over the existing brain tissue.
They replace axons, really, in the literature, so they actually short-circuit axons in the brain. They can be used for that, because I believe they're more efficient than the natural axons, which would connect the neurons normally. They've talked about that in their own literature. I'm not making that, you know, that's in their own literature. Yeah. So this next image here is more the sort of colloid structure, where you have these spherical components being added to the head and to the body of carbon nanotubes to create these swimmers. They have this sort of flagellar type tail effect where they can swim like sperm or something like that.
Mm-hmm.
Again, another image showing the same kind of sort of construction in the Pfizer that Campra showed. And then another image, the same. And then this image here, again, it really just suggests a swimmer with a head-type structure. I mean, some of these structures can actually morph, so we'll come on to that in a bit, but you could say there that you've got a tail-type structure for swimming and a head that has some other function. I mean, maybe that head is being grown from that piece of graphene oxide there.
Right.
I mean, that may be a bit in construction, if you like.
Right. So if something is being grown in that way, would that involve DNA instructions or not?
I think it'd just be a chemical thing.
Right.
I think it's a
Okay.
chemical process. These images here look to me like the microbubbles that we saw before that Dr. Camper has seen. They look a bit different because it's a different form of microscopy, I think.
Right.
But they certainly have a similar sort of characteristic to them.
So 5001,
Yeah.
we've got blood cells in there all lined up again, as we saw. Is that right?
Well, as we said earlier, we found these microswimmers in the blood. So
this is not a photograph of the vaccine. This is
no,
a
this is in the
vaccinated
blood.
person's blood.
Yeah, and you can see the rouleaued blood, and these particular form of swimmers seem to be created purely from hydrogel, which gives them a soft texture, which enables them to be less harmful within the tissues of the body as they float around the bloodstream. And I think the micronator or something was the name that Mick Anderson found to associate with these, and he found some images of similar sort of structures. I mean, clearly that's not, I don't think, a natural structure, and the doctors who've examined the blood, who've spent decades examining blood, have never seen these kind of structures in blood before.
Right, right. And
And the fluorescent nature of that image suggests it's sort of a carbon-based construction.
right.
And this next image here comes from Dr. Axel Bolent, and again he shows the similar structures in the blood. There, the image on the left is blood before vaccination. The image in the centre is 4 hours after vaccination, so you can begin to see the blood sort of rouleauing, but you can see this hydrogel-based swimmer in that image, and then 1 week after vaccination is the image on the right with the rouleaued blood and a clear image of that swimmer in the
Well, we
blood.
can assume that that's not the function of what that is, to make the blood do that, even though that's
No,
very
no.
unhealthy and very dangerous. It has some other function, and a byproduct of which, or a side effect, is it does that to your blood.
Well, I think that the blood's probably been caused by other things like the graphene oxide and
Right.
electromagnetic radiation, the combination of those. If I had to speculate as to why the blood's rouleaued, I think that just, we're just having to see two particular artifacts there of the injection that maybe are not exactly related. Okay,
So 1004,
So this image here was taken by Dr. Robert Young, and he identified this as a microorganism known as a Trypanosoma cruzi. At the time, he reckoned that it was a Trypanosoma cruzi, but when I read through the literature, I found a paper in which they talked about the Trypanosoma bruzi and having the ideal characteristics to be used as a swimmer, because it alters its shape depending on temperature and on, I think, the viscosity of the fluid that it's in, to have the ideal morphology for moving through that substance. So it may well be a synthetic swimmer, this, designed based on a Trypanosoma cruzi or
Right.
bruzi.
right. So they've taken the biology of something of one of these swimmers, they've modified its DNA and created their own version of it. But when you say synthetic,
I wouldn't like to say how they've created the synthetic
Right.
object, but they're certainly interested in doing it. They've talked about it specifically in their literature in this one
Right.
particular paper.
all right. So we've got another image from the Argentinian study here, 18006,
That's right.
and you think that's
Showing-
this payload thing.
Yes, the microbubbles. I think they've identified that as microbubbles.
And possibly also in Pfizer.
Yes, on the Pfizer there as well. They look quite like microbubbles. And then, just to sort of talk a bit more finally about the carbon nanotubes, this is from Ricardo Delgado of La Quinta Columna's video, where he talks about the behaviour of carbon nanotubes and how they react to the presence of something organic, like human breath. And he also described this carbon nanotube as having reddish colour, which relates a bit to the Morgellons, the colouring of Morgellons.
Yeah.
But what if you look at the second image here, you can see that it appears to be connected again to some kind of, I don't know if it crystalline or some kind of substance at the other end. And again, another carbon nanotube which he showed, and again the final image there shows it's the other end being connected to a crystalline substance which may form some kind of electrode, may have some function along those lines.
So this next bit, you're quite sceptical of this, but it's been suggested by Mick Anderson that this could be what's called a mesoporous carbon sphere, but you're not so sure about that.
Looking at the morphology, it doesn't look sufficiently similar for me to think that that was a positive identification.
But if it was, it's used in drug delivery.
Yes. I mean,
so that could be a payload of drugs within the vaccine that could be released at some future point in time.
Yes,
that's what Anderson is suggesting.
Yes, I mean they also have other functions. These mesoporous carbon spheres, for example, they could function as a capacitor. If you look at the actual sphere morphology, I could see that it might be usable as a capacitor, whereas this image here doesn't make me think it looks like a capacitor.
Right. I'll just mention some of my own images now.
Yeah. Okay.
Because, well, I will show a clip of me unpacking one of the vaccine vials and putting it on my microscope first. So just take a look at that. Now today I'm going to examine a COVID-19 vaccine under a microscope. You may remember that I made an appeal for people who can get some samples of the vaccine to send it to me. And recently I received some vials. This is the Pfizer BioNTech vaccine, and somebody has very kindly sent me 3 vials of it. Now I'm going to take my time with this because I'm not an expert with microscopes, but I'm filming it all because I think it's important that you see the entire process of me having received these vaccines. I'll just hold it there for the camera. 1, 2, 3. So this goes under the name Comirnaty, which, as I said, is the Pfizer BioNTech vaccine. I'm just looking to see if there's a date on there. Yeah, it says 6/2022. 6/2022. So I presume that means June 2022. And apparently they dilute these with saline before they actually inject them. 6 parts saline to 1 part vaccine. All right. Now I've got some microscope slides and some cover slips, and also a syringe, so I can take the vaccine out of the vials and put it onto the microscope slide. But I think it's important that we independently look at the vaccines and see what's in there. I'm looking just to see if there's anything anomalous, anything which shouldn't be there. If you look at images of the nanolipids that are alleged to be in the COVID-19 vaccines, they're just tiny little fuzzy spheres which are extremely small, of the order of 100 nanometers across, which you're probably not going to be able to see with a microscope that only goes up to 2000 times magnification, right? But what you should see is a fairly uniform backdrop. You shouldn't see any rectangular objects or anything like that, which is what people have claimed is in the vaccine. So as I say, wanting to do this just to get independent verification. All right, so I'm just going to take my time and prepare this slide as carefully as I can. But these are definitely unopened vials, because when you take this purple cap off, it snaps. Careful not to get my fingers on any of the poison. So this is a brand new syringe. Right, so we've got the cover slip here, or sorry, the slide. And I'm just going to take a tiny amount out of there. Just pierce the little membrane, there we go, into the bottom. Just suck some up. Okay, take it out. Just drop a little drop on the slide, there we are. Okay, I think that's enough. Okay, on very well. Put that to one side, that's the one that I've used. Okay, cover slip. These are very, very thin. It's easy to pick two up by mistake. Okay. Right. Just plonk that straight on top. There we go. Right. Let's take the slide off that I was using. I was just looking at some material earlier on. Okay. And put our slide in. As I say, I'm just taking my time with this because I am a novice. Right, we need to put that on the lowest magnification first. All right, so what did I find? Here I can show some of the images that I've taken with this 1,000 times microscope. And I did find, in particular, similarities with the Argentinian study. I would say that was the most comparable. Yeah. However, there were images that I took that I also could see in Dr. Camper's images and in other studies. So the images that I've produced convince me that the majority of the studies are genuine. I haven't found any straight-edged items, but perhaps this isn't powerful enough. But one thing that I did do, I observed the strands, the carbon nanotubes, if that's indeed what they are, and I put my microscope to one side. I was there for 5 days. The slide has dried out a bit, and I just so happened to switch it on, and I've recorded movement in a lot of the of these carbon nanotubes. So we can just take a look at some of my images of these things that appear to have come to life. And I've showed this to a few people, and they've said, "Oh, it looks a little bit like a parasite," but they're clearly not parasites because there's no head, they're just a strand, but they appear to respond. So if I tap them or if I blow on them, then they start moving about. Anderson told me to stimulate them electromagnetically, and he said they would start moving about. I've yet to do that. So if you've had the vaccine, folks, this is what's inside your body, right? And I've proven that. I've proven that with a sealed vial that I've put on the microscope, and I've seen the carbon nanotubes or Morgellons-like strands, whatever they might be, with my own eyes. So just to summarise our own conclusions at this point in time, we believe the evidence for the presence of graphene oxide and carbon nanotubes in most of the jabs is very strong. We cannot say whether quantum automata, nano antenna or self-assembly are present, because the evidence that has been suggested so far could be explained as salt crystals. However, we don't rule out the possibility. It's important to know about these developments in nanotechnology because these developments could be put into jabs covertly. We know that carbon nanotubes can be used for brain modulation, but it is unclear how this could be achieved with the evidence we have so far.